everyone, welcome. You should be on page 25 of your Algebra 1 Quarter 3 notebook. In this video, we are talking about multiplying and dividing polynomials, and we are going to kind of bring back those exponent properties into our journey. So we need to use the distributive property, and we're going to have to remember that when you are multiplying variables, you add the exponents. So remember, if I have x to the third times x to the fifth, that equals x to the 3 plus 5, which is x to the 8th. So there's going to be a lot of thinking going on here as we go throughout here. Here we've got a monomial, that's one term, times a trinomial, 3 terms. In this example, I've got 3x squared, there's my monomial, and I've got 4x squared minus 6x plus 7, trinomial. And I need to distribute through multiplication this monomial to each term inside the trinomial, inside the parentheses. So what's really happening is that I've got 3x squared times 4x squared. Then I have 3x squared times minus 6x. Then I have 3x squared times 7. Now, this is not necessary, but you can do this. First, I want to recognize here that this is really 3 times x squared times 4 times x squared plus 3 times x squared times 6, negative 6 times x, plus 3 times x squared times 7. In these little pieces that I'm adding, I can rewrite the multiplication, right? The multiplication is commutative. I can't rewrite everything, but I can do this. I can rewrite my two coefficients, 3 times 4, times x squared times x squared. Now I can move my 3 times negative 6, I'll just put that in parentheses so we remember it's negative, times x squared times x to the first. I'm going to give it a 1, so when I add, I remember that's what it does. And here I've got 3 times 7 times x squared. This is not a necessary step, and then quite frankly, this is not either necessarily a necessary step, but I think it helps you see the breakdown of what we're doing. So now I have 3 times 4, which is 12, and I have x squared times x squared, same base, so 2 plus 2 is 4, so this is 12x to the 4th. I've got 3 times negative 6, which is minus 18, and I've got an x squared times x to the first, 2 plus 1 is 3, so that's going to be x cubed. And I'm going to add 3 times 7, that's 21, and x squared is by itself. So there is my answer to this problem, with really every part of the process very clearly written out. So let's take a look at this next one, and I am going to go through all the steps so that you can see it. And as you develop more comfort, you'll get to a point where you're just like, okay, 3 times 4 is 12. That's going to be x to the 4th, and you just write it. And it's kind of a process you go through. But you need to get to that comfort level first, I think. So here I've got negative 5x. So I do have to be careful when I'm distributing a negative. Not so much with my 8, because that's positive. Not so much with my 3x squared y, because that's positive. But here I'm going to just circle it, because I'm going to recognize this is going to be a negative times a negative, which results in a positive. Here we go. I've got negative 5xy, and that is going to be multiplied by 8x cubed y squared, plus negative 5xy, which is going to be multiplied by 3x squared y. And it's going to be plus, I'll just put a plus here, negative 5xy times negative 10x. Let's rewrite, because remember, this is commutative, right? We've got lots of multiplication going on in these little factor here. Lots of multiplication. So I'm going to write negative 5 times 8, and then I have x to the first, x cubed, y to the first, y squared. Now I'm going to have negative 5 times 3, x to the first, x squared, y to the first, y to the first. And finally, I'm going to have negative 5 times negative 10, x to the first, x to the first, y. I don't need to put to the first because there's no other y, so nothing is going to combine with it. Okay, I have negative 5 times 8. That's negative 40. X to the first, same base. 1 plus 3 is 4. X to the fourth. I've got same base. 1 plus 2 is 3. Y cubed. Now I have minus 5 times 3. That's going to be minus 15. 1 plus 2 is going to give me x cubed. 1 plus 1 will give me y squared. And I've got negative 5 times negative 10. That's plus 50. X to the first, 1 plus 1 is x squared, and the y stays alone. So there is multiplying a monomial times a trinomial. Let's multiply a binomial times a binomial. And I'm going to show you two different ways you can do this. You can use a table, or you can distribute each term by using a process called FOIL, which stands for first, outer, inner, last. So if I look, I'm going to do FOIL first since I started there. I got a binomial, and this highest exponent is 1. There we've got two linear binomials, x minus 5y times x plus 5y. Two terms, two terms. What do I mean by first? This is my first term of this binomial and my first term of this binomial. So first, I mean multiply x to the first times x to the first. Outer. I'm going to go to the out and the out. This means that I'm going to add plus x to the first times 5y to the first. There's my outer. Inner. I'm going to add negative 5y to the first, x to the first. I just multiplied those. And now last. I'm going to add negative 5y to the first times 5y to the first. So first, outer, inner, last. X, well, I don't have to rewrite anything here. And I'm not going to do the rewrite process here. I'm going to kind of just pull it together. So I've got same base, 1 plus 1. I've got x squared. Now this one's a little trickier because I've got my coefficient, and that's a positive. So this is just going to be plus 5. X to the first, y to the first. There are no combining because I don't have the same base, so it's going to be plus 5xy. On this one, I've got minus 5. Well, it doesn't look like there's any other coefficient, so it's just going to be minus 5. And I'm going to rewrite it so it says xy. You should write your variables in alphabetical order. And my last term is going to be negative 5 times positive 5. That's minus 25. And I've got a y to the first and a y to the first. That's 1 plus 1, y squared. Oftentimes all the time in a binomial times a binomial, or a lot, often, we'll just say often, maybe not always, I can see that I have these same variables, same exponents here. So combining like terms, what's 5 minus 5? That's 0. So this simplifies to x squared minus 25y squared. What does a table look like? If you're not into foiling, well, I'm going to create a table. I have 1, 2, 3, 4. So I have 2 rows, 2 columns. I'm going to go like that. So for the 2 rows, I'm going to put 5x minus 2, 6x plus 1. And now I'm going to multiply, kind of like a multiplication table. Here I've got 6 times 5. That's 30. X to the first is going to be x squared. Now I'm going to multiply 5 times 1, and that's going to be an x. Now I'm going to multiply 6 times negative 2, and the x stays. And negative 2 times negative 1 is negative 2. Now, when you use a table, you are going to find that you are always going to get a diagonal. That is where you'll find your combining like terms. So I'm going to take my first term, 30x squared, that has nothing to combine with. Negative 12 plus 5 is minus 7x, and my last corner will have nothing to combine, minus 2. You can use either strategy for any binomial times a binomial. It is your preference, but it's nice to know that you have different ways to go about it. This is what we will call a special case. Okay, so might be a big fat break in there that I'm going to have to cut out. But what we've got here is a special case. And this special case is actually called the square of a binomial. A lot more focus on square binomials in the future. But what this is saying in squares of binomials is you want to rewrite them. And how I would rewrite this is a plus 5b squared. So I am multiplying a plus 5b times a plus 5b. That looks like a 9, kind of, doesn't it? So really, if you think about it, what I've got here looks an awful lot like a binomial times a binomial, and it is. It's just the same binomial squared. So what I want you to consider is that you can use the table or you can use FOIL. And I'm going to use FOIL because that's what I used when I was growing up. And here I've got a times a. That's going to give me a to the first times a to the first. I'm going to have my outer plus, so I'm going to add 5b times a, my inner, plus 5b times a, and my outer plus 5b times 5b. And that's to the first. I'm just going to give them their ones because I know I have the same base and I'm going to be combining them. I have a to the first, a to the first. That's going to add 1 plus 1. I've got 5. I'm going to rewrite this quickly so it's alphabetical. And you can see that it is the same x variables, same exponents. So 5 plus 5 is plus 10ab. And 5 times 5 is 25. 1 plus 1 is 2. And I've got a squared plus 10ab plus 25b squared. And now I've got the square of a binomial. That's it for this video. Thanks so much.